Test. Alright, everyone. Hi. Sorry for the wait. Thanks for being patient with me. Just got back from class. So, this meeting shouldn't take more than about an hour. Let me know if there's background noise. Basically, there are two main... Wow, it's really loud back there. I'm sorry. Basically, there are two things I want to get done during the meeting. One is about the TikTok, which should be pretty quick, and one is a bit longer. It's about breaking down our... Starting to move into the coding portion of this research. We're going to kind of brainstorm ways that we could break this down into smaller parts, and then, yeah, go from there. But we'll start... And by the way, this will be recorded, so I'll post it on YouTube later on and just link it to you guys. So, yeah. I'll start with the first part. The first thing is the TikTok. You might have seen the TikTok channel in the research section of the Discord. I posted and pinned the rules for it, but basically, for STEM month, we're going to make a 60-second video, basically either on our research or STEM in New Jersey or Governor STEM Scholars in general, either one of those. Just follows the rules of a TikTok, 60 seconds. We all have to be somehow involved. I don't think we all have to be in the actual video. But yeah, this is going to be due on Monday, this coming Monday. So yeah, I was thinking that on Saturday when we all meet for the conference meeting, we just think up ideas, brainstorm some stuff. Hopefully by the end of the day we have an idea. And then on Sunday we record, edit, and then get it sent out by Monday night. Monday we could kind of have as a padding day in case we don't finish in time. But yeah, I was curious, do you guys have any ideas on STEM videos we could make? Anything? Alright. That's fine. Oh, one more thing. I was supposed to do this at the beginning, I completely forgot. Since I guess this is the first time you guys are actually meeting with your sub-teams, I thought it'd be a good idea to kind of go around, introduce yourself, say any preferences or anything, and then just talk about how your day was. So I guess I'll go first. I'm Zane. You just call me that. My day was okay. Long day. Fell asleep during lecture like 3 times. Didn't get caught though. It's his fault for turning off the lights. I have a class that ends at 11 p.m. unfortunately. But yeah, guess we'll go in order. So Elena, you want to just introduce yourself and say how your day's been going or anything else?
Okay. I'm Elena. My day's been going fine, I guess. Just been catching up on homework. That's a lot.
Cool, nice, yeah. Maha, you want to go for it?
Hi, I'm Moho. My day has also been fine. I had an art club meeting today, and I've just been doing homework since.
Nice. And then Sophie, go for it.
Hi, I'm Sophie, and my day's been fine. I've just been doing school and homework.
Nice. I'm sorry. You guys have so much work. I'll try and keep this quick then. You guys can get back to your stuff. Thanks for taking time out on a weekday night. Really appreciate that. Okay. So we've gone over the TikTok, kind of introduce ourselves, kind of get our voices out there. So this next part is what's going to take up a little more time. I'll share my screen real quick. Show you guys how to open that up. Give me a second. Okay, I've shared my screen. If you look on Discord where my username is, like where all of us are, if you just click on the button live, or should be a pop-up right next to it. If you click on that, then you should be able to look at my stream. It might take a second to load, but just yeah, wait till you guys all get on there. Oh, all of you on. Never mind. Sorry. Okay. So I'm kind of gonna take a step back and talk about, I guess, computer science a little more theoretically for a second. Not too theoretically, it's basic stuff. You guys might already know it. But very basically, if we think of computer science, you might have seen that if you watched the first coding video, it's fine if you haven't, but basically we could think of computer science more broadly as this process of this black box, which is the code we write and all this stuff, and it'll basically somehow feed it some inputs. It gets processed by the code, and then we'll get some outputs. Very, very broadly, this is what it is. This is how MIT starts out their ComSci course, Harvard, CMU. This is the picture that they like to paint of what computer science means in the most simplest way. So more broadly, I guess we could talk about what our code is doing. Although I think I could hone in on this a little more. So basically right now, if you've ever done computer science before, which a lot of you have, with your assignments, you're probably going to be given a task like make a calculator or loop through this or calculate this. And it's just going to be pretty simple inputs if there are any, and then an output, and just the code is one big block. But when it comes to really, really big projects, like what we're doing with our research project, where we're graphing stuff, we're processing data, we're pulling files, we're looking through a bunch of files, all this kind of complicated stuff, it doesn't really work to just have one big block of code just go line by line. Reason being is that, especially because we're working on a team with up to 10 people, and by the way, guys, if you have any questions, feel free to interrupt me. I don't care. I'm completely fine with it. But yeah, when we're working with like 10 plus people, it doesn't really make sense to have everyone kind of working on it line by line, because then you're kind of rate limited by you can't go ahead. You have to kind of finish the parts before. So the way we kind of get around that is, instead of having one big block that does all of our code, we kind of break it down into smaller and smaller pictures. So we'll have what's called functions, if you heard of it, that'll do an individual task. So if it's like if you want to think of like a quote unquote algorithm for like cooking something, instead of just having all the directions like, okay, just make something and put it out the door, one person does all of it. It's more efficient to think of it as, okay, we're gonna have one person who, if we're making something, I don't know, like prepares the rice, one person who will cook the chicken, one person will watch the vegetables, one person will cut it, one person will cook it, one person will plates it, kind of delegating all these tasks where everyone can work on something at the same time, and that way just the whole process goes along a little more efficient. Now, in order to do that, one thing that's really, really important is that we have to have our inputs and our outputs very, very clearly defined. You have to know the number of arguments. So I'll actually open up an example. Sorry, it's gonna my lag a bit. Let me open up my GitHub real quick. So in case you haven't seen any functions before, it's pretty basically something like, it's loading, sorry. Yeah, pretty basically something like this, where you're gonna have a function name and you're gonna have these inputs. My inputs aren't amazingly defined. This is Python. I have another example that I could pull up, but basically, you want to have your inputs very clearly defined. So in this case, the inputs would be max, spacing, and limitless, and the outputs would be intervals. And you want to say, okay, max is an integer, spacing is a list, limitless is a boolean, and that's something that you'd want to ideally put right here. This is a comment, often called a docstring in industry. Yeah. I wrote one sentence, but you should write more. Actually, it kind of describes. So spacing, it roughly describes what each variable is going to be. For an example of a better looking doc string, could open MGS. Well, this is a completely different research project I'm working on. Looking at Mars magnet stuff. But yeah, this defines it very well. So if our input says file name, it's going to say, okay, your input is going to be file name. Your outputs are going to be all of these values here. And this is written in MATLAB, by the way, so you don't have to understand the syntax. But these are all of the outputs. It's going to explain, okay, pause is this, mag is this, all these are the, and it's going to pretty much explain what all this is. Basically what this allows you to do is that the person who's, let's say if in the cooking line, you're the person who cooks the food and the person after you is the person who puts it on the plate, they don't need to know the specifics of they don't need the specifics of like how you're going to cook it, what kind of sauce, or how long you're going to cook it for. All they need to know is you're going to give them X, Y, and Z items, and so they know how to plate it. They could come up with a plan on how to plate it. They don't have to know the specifics of how you're doing it. So basically, the conclusion for this is you want to have your inputs and your outputs very, very clearly defined as we start working on these parts. And this might seem a little tedious, especially if you've done computer science things on your own before. You've probably never heard of this kind of stuff, and it sounds kind of a lot. But whether you're working on research projects like this, or you're working in industry especially, I've talked with a lot of people who like go to Carnegie Mellon, and my brother is a software engineer at a bank. When you're working on a team, this is so important. Like 90% of your training is going to go into how to communicate properly, how to write good documentation, how to clearly define this stuff, how to do unit testing. There are entire like packages that are dedicated to just making sure everything works together and all your inputs are well defined, all your outputs are well defined, and yeah. Sometimes even before you'll run your code, you'll have tests that see, okay, are all of my inputs of the right type? If I have some basic inputs, does it give me the right output? It's called unit testing if you want to look into that any further. But yeah, this is basically the idea of breaking down code into smaller parts, like how if you're in a kitchen, you might want to break making food down into smaller stations so everyone can work on that at the same time. So on that note, I kind of made this document. So the purpose of this meeting is that, and I'll link this to you guys later. Don't worry, you don't need to get it right now. But the purpose of this is going to be I want you guys to brainstorm some ways that we could break down our research project into smaller parts, these smaller functions I was talking about. But first, I guess I'll ask you guys, does anyone want to kind of try and summarize our research or what they understand our research to be real quick? Anyone can just unmute and speak up. Okay. Come on. Okay, that's unfortunate. I'll go ahead for it. It's fine if you guys are tired. I'm tired too. More broadly, our research is essentially taking these netcdf files, and I'll open pan up in the background as well. It's taking, basically we have satellites take pictures of the North Atlantic, and they return them as these things called netcdf files. That's the format the data is kind of collected in. And those netcdf files, if I can open it up, data, yeah, this should work. Hopefully it works. Is half the thing just missing? Interesting. Very interesting. Okay, I guess. Let's not use that file. I should look into that. That's kind of concerning. I like band 13. Band 13 never fails me. Until now, I guess. Yeah, this one's a little better. So basically, this is kind of a visualization of what the netcdf file is going to be. I don't... Wait, give me a second. I'm just going to change the scaling a little bit because I don't like the way it's colored. 50. There we go. This is colored so that the white stuff is cloud and the blue stuff is ocean. And so this netcdf file, this is kind of a visualization, but the data itself is actually just a big 2D array, if you've ever heard of those. You see a grid of numbers. You could think of this as like an Excel sheet where every pixel is like this. The x-axis is the latitude or longitude. It's flipped in a weird way, but this might be longitude or latitude. The x and y are longitude and latitude, and each pixel will kind of correspond to a location, and it's going to have some value associated. So if you see right here, the value of this one is about 14,909, and that's ocean. But if you go to a very bright region, well, now it's 2,000. It's way, way lower, and that lower value corresponds to a cloud, basically. And so, this is the input of our, more broadly, our script. This will be the input of our code. These kind of arrays representing, this is one snapshot in time. You might have seen before, we have an entire folder of a lot of these netcdf files over the course of a hurricane. And our goal is to basically take all of these files and come up with a plot. Yeah, we want to come up with a plot, something like this, where on the x-axis we'll have time. So as time goes on, from the beginning of a hurricane to the end of a hurricane, what percent of the land is covered with cloud. So I'll put %cc for percent cloud cover. And what I mean by that is that if you look at this picture, it looks like maybe a little less than half of the ocean is covered by clouds, right? Because you have like this big area that's water, a little bit that's cloud, water, cloud, water. Less than 50%, maybe like 20, 30, 40% is covered by clouds. And so maybe at this moment of time, if this is like 100% cloud cover or 1, and this is 0, let's say maybe this is like about 40. And then if we have another moment in time and it's like in the middle of the hurricane and the entire thing is covered by clouds, like the entire thing is white, then we might have a much higher cloud cover like that. And we basically want to come up with one of these graphs. The rough shape we expect to have is that we don't have much cloud cover, just like about normal. Once the hurricane starts, there's going to be a bunch of clouds that are basically going to cover the entire region, and then as the hurricane goes down, it's going to fall. We expect a shape roughly like this. And I have some graphs like this. I produced some of these myself. You guys are basically just going to be recreating them. Something like this, basically, yeah. This is a good example. So it's going to be something like this, day of the year on the x-axis, percent of the North Atlantic covered on the y-axis, and it's going to be something like this, where over the course of the hurricane, like at this point, 80% of the North Atlantic was covered. Gets a little lower, but yeah. So we have our netcdf file. Basically what we're going to do, this is the goal of our output, and the way we kind of calculate the cloud cover is that if you look back at the actual what the netcdf file is, it's just an array of numbers, all of these integers. Basically going to go through all of these. If I could simplify it, instead of having like, what is this? The dimensions of this are very big. It's like 267 by 171 things. Instead of doing like something 200 by 200, I'm just going to do a simple 3 by 3 grid. Let's pretend this is a very simple netcdf file. I'll put in some like simple integers in here. So like maybe this is 0, this is 1, no, let's call that 8. Let's call that 10, let's call that 15, let's call that 2, 20, 4, 7, 13. So basically what we're going to do is that we're going to choose some, these all represent like values in the array for like what it is. And in general, lower ones correspond to clouds, higher ones corresponds to ocean. In general, what we want to do is that we want to pick some arbitrary threshold. So what's the range of these values? It's about from like 0 to 20. We want to pick some, what I like to call a threshold, and I'll just call that TH. Let's say in this case our threshold is like, I don't know, 14. We'll say that our threshold value is 14. And pretty much anything below that here, anything in this range is a cloud. And anything in this range is just ocean, just water. So the way that we do that is we're pretty much going to go over this entire array, and we're going to look, okay, 0, that's below our threshold, that's below 0 and 14, so we're going to say, okay, this is a cloud. 8, that's below our threshold, so there's a cloud. 10 is below cloud. 15 is above, so this is water, or ocean, same thing. 2 is cloud. 20 is water. Cloud, cloud, cloud. And so now that we've designated all of these as either clouds or water, I want to go through and say, okay, so these are 9 total pixels. So our total is going to be over 9. How many clouds do we have? We have 1, 2, 3, 4, 5, 6, 7 clouds here. So we're going to have a cloud cover of 7 over 9, or whatever this happens. And this will evaluate to the number. And on our graph, that's going to give us some value on the y-axis. So this is going to be a netcdf at a certain time, like a 2D array at a certain time. And then we're going to plot that. That's going to be our x value, or our horizontal axis value. And then our y-axis value is going to be this number that we get, 7 over 9. Using that, we're going to get a point, and then we're going to repeat that with the next moment in time, and the next, and next, and next, and we're going to do that over the course of the hurricane. Pretty much just going to get a graph like this. So yeah. Oh, wait one second. Wait, I'm sorry. My headphones are dead the entire time. If one of you guys said something before, just let me know again. I'm sorry. That's bad. Yeah. But yeah, any questions based on what I've said so far? I'll give it a couple seconds.
What is the like unit of measurement of the data that's in the tables?
Yeah, really good question. So if you look at the actual graph, it says raw satellite counts, and it'll have this kind of scale here. I don't think there's an actual unit of measurement. I think they literally just send each band corresponds with the wavelength of light, so they're literally just sending a certain wavelength of light and measuring like how many kind of I guess particles of light are we recording that bounce off of there. So I guess for the clouds we don't record much, and for the water we record a lot, but the unit isn't as important. It's more so what's the actual raw number, because you'll see these vary from file to file. But yeah, does that answer your question?
Yeah, that makes sense.
Okay. Any other questions? Cool. We'll get moving. So, yeah. So more broadly, I guess, I'll share this. You guys should all have access. I'll put it in the chat for you. This is kind of this is gonna be the doc we're gonna be working on for the next while. But if you got, I'll give you guys like a couple of seconds to open that link. Am I allowed to share it actually? Yeah, I'll let you share access. Cool. Nice. I just wrote some pretty basic stuff. The questions is any questions you have over the course of the time. If you don't want to say them, you're just going to type them out here, or research questions in general that you want to get answered eventually. So kind of, and you can look at either my stream or you could look at the doc itself. It doesn't really matter. The input. So overall, the goal of our code, the input is we're going to have like a folder of netcdf files over the course of the hurricane. And these netcdf files are going to be, I guess, 2D arrays of integers. A 2D array meaning it has like kind of like a horizontal component and a vertical component. Like you could have a 0.21 or 510 or something like that. An ordered pair of points with an x and a y. It's a 2D array. Yeah. And our output is going to be, and I'll just post a picture of this graph. Our output is going to be a graph like this, which is plotting time versus cloud cover over the course of the hurricane. And that's going to look roughly like this. Yeah. So yeah. So I guess this is where I kind of turn it over to you guys. And this is where I take my hands off for the most part, and I ask, at this part near the bottom, I wrote a little template. So what we were talking about before with task breakdown in terms of having individual functions. Like I said, we want a name for our function. We want a description of what it actually does, and then you could fill it in. The inputs defined, so however many you need, 1, 2, 3, maybe you don't need any inputs, and then some outputs. And those outputs are just going to be, yeah. So I'm basically asking you guys to break this down and come up with some ideas on intermediary steps. And there are no right or wrong answers, by the way. On Saturday, we're going to kind of come together and combine all of the other teams have come up with functions too. We're going to combine them all into one plan of action, and then we're going to kind of assign functions for you guys to start coding yourselves. So yeah, if you want to speak up or if you just want to type, anything like that, just come up with anything. It doesn't have to be the first thing, it could be the last thing. But yeah, what needs to get done? How could we break this task up? Go for it. Yeah, anyone's free to unmute now.
Okay, so we are going to do
You guys have any questions or ideas, or it doesn't have to be an answer. If you just want to ask something, that's fine too.
I'm still kind of confused on like what exactly I could be writing.
Yeah. So do you understand do you understand what I mean by breaking down our bigger code into smaller functions? Does that make sense?
Yeah, I understand what that means, but I'm not sure like which code.
Yeah, so we haven't written that like big piece of code yet. All we know is that overall, the code should be doing this. The code is like kind of defined at the top where we want to take a folder of netcdf files and we want to output a graph. Now we could do that all in one go. We could just write one big like 200 line code script that's going to do that. But instead of doing that, we want to write like smaller functions. So let's say an analogy would be like if our input was like some ingredients and our output was I don't know, pizza, then the functions I'd want you guys to write is like, okay, first one is like wash ingredients, the input is going to be ingredients from the bag. I don't know, or bags of ingredients, and then the output is going to be washed ingredients or something like that, and then the description should be take ingredients out of the bag, wash them, whatever. Next one might be cut up vegetables, and you're basically just going to list out functions one by one by these, kind of breaking the thing up. So does that kind of answer it? I might have gone a little off topic.
Yeah, that kind of makes sense.
Okay. So I guess with this, and I don't expect you guys to know everything right away, of course. This is literally just the brainstorming phase. Just any idea of like, okay, at some point we have to do this. Like at some point we have to make the graph, or at some point we have to look at a file or something. It could be something as simple as that. So yeah, just feel free to unmute and throw something like that out. So I can help you guys along. I guess if we start with our input, so the input of our program is going to be the input of our first function as well, obviously, because I guess it's the starting point. Like if the input for our pizza thing is ingredients, and the first one is going to be dealing with those ingredients. Unless you want to preheat. What's that? Sorry, I had to sneeze. Yeah, so I guess, what's the first step? If I were to give you a folder of netcdf files, what do you think you'd have to do with them next?
Open the folder, get
Yeah.
the data.
Yeah, it's a perfect one. So our first one, and I'll kind of write it along to help you guys get started. So the first one could be open, instead of open all of them, maybe open one netcdf file. Or here, we'll call this, we'll leave the name undefined for now. But we'll just say our description is open one netcdf file. And what else did you say?
Read the data from the file.
Yeah, good idea. Open one netcdf file and I guess read over the integers. And what do you want to do with those integers? Do you want to like count them, or do you want to threshold them, or do you want to sort them, or anything is valid, literally any approach. Do you have an idea for anything?
Maybe like split into X and Y and then do the threshold on the X.
So for the X and the Y, do you mean X and Y on the graph, or kind of X and Y in the 2D array, like these?
On the graph.
Yeah. So on the graph, the X and the Y is going to be time. So what we're going to put on the time axis is the actually, it's part of the name of the file. So this individual netcdf file contains this 2D array, and the title of the name of this netcdf file is 2012.292. It's going to be like year 2012, day 292 out of the year, out of 365 days, of course. 20 hours, 20 minutes, and 15 seconds. So that's going to be what's going to end up going on our x-axis. It's going to be our time value. These x and these individual y values, we don't want to actually plot these, because these values, like, this isn't associated with the graph. This is just kind of, those get directly mapped onto this, and Panoply basically colors them according to how big the number is. The number is bigger than the pixel is bluer, basically. You can see this if you go here and turn that off. You can see very clearly how it's just individual pixels. But yeah, so we don't want to exactly put on the x and the y axis. Remember, with this example, with this netcdf file, imagine we open this file, the simple 3x3 netcdf file. We kind of look at this array. We're looking at all of the numbers, and what did we do with the numbers? Let's see how much I could undo. Yeah, what did we do with the numbers?
Thresholded them.
Oh, sorry, one sec, my headphones. Yeah, I'm sorry if that happens. If I even nudge my headphone jack, they just completely unplug. I'm sorry. What'd you say?
I just said that you thresholded the values.
Yeah, that's perfect. Oop. Yeah. Sperm and egg. I call my mom sperm and egg donor. It's awkward. I'm sorry. This looks like a weird text. I'm sorry. Just ignore that. Yeah. So perfect. We thresholded the values. What does it mean specifically to threshold a value?
To determine if it's a cloud or an ocean.
Yeah, and we basically just checked if it was above or below our threshold value. Perfect. So we could say this function reads over the integers and thresholds. We would just say in general thresholds the integers. Or we could call these pixels. Does it make sense if I call them pixels? Like each cell in this 2D array is kind of like a pixel. So like you could kind of see this more directly. If we go to like let's say this random pixel. This is pixel cell. It says all the way at the bottom line, cell 3043. So that's pixel that corresponds to, like, if we go to like x30 and y43, then we'd find the same exact value. So each one of these values corresponds to a pixel on this. So we'll say threshold the pixels, or threshold the pixels or cells or whatever you want to call them, by kind of seeing if they're above or a certain value. And yeah, so now that we've kind of classified them, what do we want to do with this classification? Or what did we do next in our kind of example?
Did we then find the percentage?
Yeah, we basically counted the number of cloud pixels. We divide them by the total number of pixels. So yeah, thresholds pixels counts the number of cloud pixels which are below the threshold and the total number of pixels. And then returns the percent covered, I guess you could say. And the percent coverage is cloud divided by total. Cloud pixels divided by the total number of pixels. Yeah, perfect. So this is a perfect description. This is absolutely is a really good first step for our program. So it'll take one file, do what I did with this paint file, and basically go over this, and it'll give you, yeah, it'll give you this ratio, and this ratio ends up getting put on this graph that we have up here. This will be one single data point. And then eventually we'll have a bunch of these, and we'll draw a line between them, but that's getting ahead of ourselves. What do you think are the inputs for this function? Or the outputs, either one.
I guess the input would just be one CDF file.
Sorry, it came undone again. You said the input would be one.cdf file?
Yeah.
Okay, yeah. One.cdf file. Perfect. What do you think would be a good idea? Or do you think there are any other inputs? Or is that it?
And the threshold, I guess.
Yeah, perfect. You're actually the first one who got that. Yeah, we want to input a threshold value as well. Great job. Cool. Yeah, we want to input a .cdf file and a threshold. Can you think of any other inputs, or I think that's it? That's about it. Trick question. Sorry. Yeah, that's it for our inputs. We just want a .cdf file, and we'll figure out what it means to like get a .cdf file in Python, and then yeah, a threshold number. So we should specify that this will be a. For now, I'll kind of give you guys the answer. This will be a string, which will be like the name of the file, and the threshold will just be an integer. So you want to specify the types. That's important when we're doing the input. You want to specify, okay, this is a string and this is an integer, because the person needs to know whether they should expect like a string or, I don't know, like a path to a file or the file itself, which you can't really do with Python. Sometimes you can. Or maybe like a Python object, yeah. In terms of output, what do you think the outputs of this are going to be?
The ratio.
Yeah, good.
Which would be a decimal.
Perfect. Decimal. And then what else? There's one more. This one's a little more subtle. Let me know if you want a hint.
please.
No worries. Yeah, so I guess when we get 7 to 9, or 7 over 9 in this example, 7 over 9 is what we'd end up putting on the y-axis of our graph, right? That's a value we plot like maybe somewhere around here. So we have a y value for our graph, but when we have a point, we can't just have a y value. What else do we need to plot something?
Time.
Yeah, so we want to output the time as well. Nice. And time, I'll just tell you guys it's a decimal for now. We'll get more into the format later. We'll just put decimal question mark. Yeah, these are the two things that you want. And these two together will give you a point for the netcdf file. So one file is going to give you 1 point on your graph. So yeah. You want to come up with a name for this function? Anything? This I'm not giving you. You have full control over what you call the functions, as long as it makes sense. Okay, never mind. I'll just give it to you. You could call this like, there are a bunch of things. You could say like process one file. That's one option. Or you could do like threshold file or threshold NC. There are a lot of things, as long as it's like clear what you mean. Threshold NC or process NC, something like that. Yeah, these are all possible names for your function. So, and when I say name for a function, I mean like in your Python thing, you have def and then the name of, so mine is create underscore intervals. This one is create underscore histogram, inputs and stuff. So yeah, perfect. We've come up with our first function, and I know we have about 20 minutes left. I'll try and get us in quickly. I guess now that we have these points, what do we want to do next? Or now that we have a function that does it for 1 point, I guess we have one station in our script, one function in our thing, one station in our kitchen, sorry. What do you think our next function could be?
Could it be the same thing but for another file?
Yeah. So we have one function. So basically, the power of functions is that you could call them over and over and over again. You don't have to repeat. You don't have to copy paste this code. So you call threshold NC over and over again. So what's one way that we could kind of like call this function in another function for all of the files? Kind of give the answer away, but what would we do there?
You would call the function that we just made in the loop over and over.
Perfect. Absolutely perfect. Yeah. We could call this process underscore all or something. Description would be loop over all netcdf files and call, let's give it one name. We'll call it threshold file and call threshold underscore file on all of them. Nice, nice. So what would our input for this be? Sorry. Yeah. So an input for this one would be, so if this one takes one file, over the course of process all, we're going to be doing this for all the files. If you want to take a look, I think it's in Matlab. Input we're going to give it a folder of netcdf files. And it's basically just going to loop over all of the netcdf files. It'll specify it in a folder and call netcdf on each of them. Oops. Yeah, and call threshold file on each of them. Yeah, cool. So that's going to be our only input. We could give this. We could also give this a threshold value. It must be similar to integer there, and then it's just going to give the same threshold value to threshold file. But yeah. And so if the output of each one of these threshold files is a point, a time value and a ratio value, so an x and a y value, what do we think the output of this is going to be?
Like an array of values.
Oh, perfect, yeah. An array of points of form, and we'll just say time, comma, ratio. So like when I say an array of points, I mean like it could be like for the, spin this a little bit. I'm writing a little bit on the stream in case you clicked out of that. So if a function is like y equals x squared, then the points associated, this would be an array of first 1, 1, then 2, 4, then 3, 9, and so forth. You get the point. So it's going to be, each of these is a single point on the graph. So 1, 1 is a point on this graph of y equals x squared. 2, 2, oh, what happened? 2, 2 is a point on the graph, 3, 9, and so on and so forth. So yeah, it's going to be an array of points like this. That's perfect. You want to have it in this format first. And then, now that we have these points, what do we want to do with these points?
Graph them.
Yeah, perfect. Have a make underscore graph. And this one is a little more fuzzy. Make a graph. That's the final output of our program. Input is going to be a set of points from process underscore all. Usually I'd have you guys write these, but you guys are probably tired. I want to get you guys out as soon as possible. You're already giving me a lot of your time on a Wednesday night. Yeah, and then our output is going to be a graph. This is a little more fuzzy, so with this, you're going to want to look up a library called Matplotlib. I'll just write it on the doc. Computer's slow, sorry. It's a 4-year-old computer. A graph. It's the final output of our program, or our script or whatever, with Matplotlib. If you want to look that up in your free time, you don't have to. I'm just kind of saying if you want. This is the Python program that we're going to use to make these nice graphs with an x-axis, a y-axis. Inputs is going to be a set of points, and it's going to kind of title it and all that. Yeah. So yeah, this is a pretty robust way to approach our thing. We're going to have 3 functions. You could break this down into more or less. Other teams did, I think one team did like 5, another team did like 2 or 3. No, I think the least they did was 3, and it's fairly similar to this. But yeah, this is basically how we break down our thing. So we could have 3 people or 3 teams working on each one of these functions at a time, and it's basically just going to, yeah, it's going to help us do it. So in terms of like the actual code, like I was saying before, before you might have all of the all the code is like a very big line, like 200 lines. You might separate this with sections, but in our script now, though, if assuming we have these functions made, it would literally just be like process underscore all, and then a folder of files, and then that's going to call process all or process each file within it, and then we're going to make graph. Let's say our points are equal to the process all. We're going to call our make graph of our points, and that's really it. Within, of course, the functions are going to take up a lot more space, but with 2 lines of code, we've effectively we've effectively done all of our work. With these 2 lines of code, we have our entire program. And this makes much more readable code. Is that okay? We process all the points in this folder, store these points, and we make a graph of these points. It's a lot more readable. And if you want to know actually what each one of them does, if you want to dig into it, you could go up to the actual function definition, look at the code that we did here. So yeah, any questions on what we've done so far? Cool. Cool. So that pretty much wraps up everything I wanted to talk about, and I'll summarize real quick. So first, with this coding stuff, you guys don't have to do anything regarding this. If you want to look into it or start coding some stuff up, or looking at Matplotlib, or importing files into Google Drive. By the way, we're going to be doing all of our coding in Google Colab. Talk more about that later if we have to. And if you have any questions, feel free to message me. I really like teaching this kind of stuff. But yeah. Yeah, so for coding, you guys don't have to do anything. I know you guys are busy, so you could just kind of wipe this from your mind. Maybe think about it every now and then. Don't completely forget about it. Don't completely wipe it. So yeah, that's the second thing we went over. For the first thing, for the TikTok, that is due on Monday. So if you guys have any like creative video ideas or you see like a cool STEM video, like feel free to post it in the TikTok chat or just kind of save it for later. And on Saturday, we'll kind of work more about coming up with an idea, recording it, and doing all that. That's kind of a little bit more of our priority right now. But yeah, I'll make an announcement probably in a bit, maybe either later tonight or tomorrow morning, saying that on Saturday we're going to have another meeting, either as part of the conference or sometime later in the night, where we're just going to kind of get all together. And yeah. So in one sentence, you don't have to do anything for the next meeting. Just think about some TikToks, and I'll talk to you guys again on Saturday. I'll post a recording of this too. So yeah, on that note, do we have any questions? Or concerns or comments or anything? You can message them afterwards as well. Stop streaming. Okay. On that note, I think that's all. Again, thank you guys for giving me your time on a Wednesday night with schoolwork. I'll let you guys get back to good luck with all your stuff. If you need help with school stuff, I can try and help. I took a lot of AP classes and stuff, comp sci, physics, calc, writing. I'm happy to help you with like your homework if you need or get resources or anything like that. But yeah, that's all for today's meeting. Take care, guys. Bye
Thank you.
bye.